Okay, so in this video we're going to start our next unit, which technically speaking is actually Unit 6. And this unit is called Momentum and Impulse. So this is going to be the last unit of the semester, whoop whoop. And this is continuing under the branch of mechanics. Remember, mechanics is the study of motion, or it's the part of physics that studies motion and how things move. And basically everything we've been doing so far this semester has fallen under the branch of mechanics, and momentum and impulse is no exception to that. Okay, and so momentum and impulse, this unit has to do with things like, how do airbags work, how do seat belts work, jumping and landing, and how those affect your body, car crashes, recoil, anything involving collisions falls under momentum and impulse. So anytime you see a situation involving a collision, you should immediately think momentum. Explosions, things of that nature. Okay, so in this video we're just going to do the very, very basics and introduce the concept of momentum, and then in the next couple of videos we'll do some calculations, some more in-depth calculations with momentum. Okay, so first of all, let's define what momentum is. The momentum of an object is defined as the product of an object's mass and its velocity. Okay, so momentum is mass times velocity. Now, for reasons which I don't really understand, the symbol for momentum is a lowercase p. Okay, so when you see a p, think momentum. And so based off of the definition of momentum, that is just mass times velocity. Okay, so and don't ask me why p is momentum. I realize it doesn't make any sense. I know why it's not m, because we already use m for mass. But I don't know why p. That would be a good question to find out the answer to, but I don't know exactly. So momentum is mass times velocity. Basically, I think of momentum as the amount of oomph an object has. An object with a high momentum is basically harder to stop than an object with a low momentum. Okay, so for example, if you have a fast-moving bullet and a slow-moving train, you don't want to get hit by either of those things. Okay, a fast-moving bullet has a very small mass, but a very large velocity. And a slow-moving train has a really, really big mass, but it might have a very small velocity. Either way, both of those objects are going to have a lot of momentum and could be very difficult to stop. Okay, so momentum, again, mass times velocity. Now, the unit of momentum, if you look at the equation, mass times velocity, we know that the unit for mass is the kilogram. Okay, there's still some confusion over mass and weight. Mass is measured in kilograms, whereas weight is the force of gravity acting on an object. Okay. Velocity, we've seen velocity since the beginning of the semester. Velocity is measured in meters per second. And so if you multiply kilograms times meters per second, you find out that the unit of momentum is kilogram meters per second. And so that is the unit for momentum. It doesn't have a fancy name like newtons or anything like that. It's just kilogram meters per second. Okay, so that is what momentum is. Okay, the product of an object's mass and its velocity. So now we're just going to do some very basic examples and calculations using the definition of momentum. Okay, so pause there if you need to finish adding that to your notes. Okay, so example 1. We have a 1,500 kilogram car travels down the road with a momentum of 30,000 kilogram meters per second. Calculate how fast the car is traveling. Okay, so we have, as we're identifying our givens, right, we have our mass, which is 1,500 kilograms. We can tell that from the unit, of course, because mass is measured in kilograms. And we're told it has a momentum of blah, blah, blah. So we know that this number's got to be p, which is momentum. We could also figure that out by looking at the units, because kilogram meters per second is the unit for momentum. So my other given here is p equals 30,000 kilogram meters per second. Now, momentum is mass times velocity. So the question how fast is always asking about velocity. That's going to be our unknown. And of course, this is just a very, very basic example. but I just want you to see what it looks like. So the equation is, of course, P equals M times V, and then we're going to substitute and solve. P is going to be 30,000, M is going to be 1,500, and that leaves V by itself. And so to solve, we would just divide both sides by 1,500. And if you do 30,000 divided by 1,500, of course, you get 20. And that's 20 meters per second. And that's how fast the car is traveling. Okay, so just a super easy calculation using the definition of momentum. Pause there if you need to look at some more. Okay, so let's move on to example 2. Okay, so example 2 says a baseball with a mass of 0.15 kilograms is thrown at a batter with a velocity of 45 meters per second. After the batter hits the ball flies back towards the pitcher with a velocity of negative 35 meters per second. You might be wondering, why is the first velocity positive and the second velocity is negative? It has to do with direction. Okay, so remember the difference between mass, or the difference between speed and velocity is that velocity has direction and speed does not. So the negative sign right here basically indicates that the velocity is now in the negative direction because it's going backwards towards the pitcher. Okay, so that means momentum can also be either positive or negative depending on direction. So in any case, the momentum of the baseball when it's first thrown by the pitcher, of course, momentum is just mass times velocity. And so normally I would use guess to solve this, but I really don't even need to do that for this problem because it's such an easy calculation. The mass is 0.15 kilograms, so 0.15, times the velocity of 45 meters per second, because that's how fast the baseball was thrown by the pitcher. It says that in the first sentence. So times 45. Okay. So in my calculator, I'm just going to type in 0.15 times 45, and I get 6.75. Remember, the unit for momentum is kilogram meters per second, and that is the answer to my first question. Now the second question says to calculate the momentum of the baseball after it's hit by the batter. Again, very easy calculation. The equation for momentum is just mass times velocity. The mass of the baseball is the same. Now the velocity after it's hit by the baseball is negative 35 meters per second. And again, that negative sign, all that negative sign indicates is direction. So it's going 35 meters per second, but it's traveling in the negative direction because it's going back towards the pitcher. So in my calculator, I'm just going to do 0.15 times negative 35, which gives me negative 5.25 kilogram meters per second. Again, yes, momentum can be negative if the object is moving in the negative direction. Okay, so direction does matter with momentum. Okay, so pause there if you need to look at that. Again, these are just very, very basic momentum calculations. Okay, so example 3. I want you to try to do example 3 on your own. I actually got these numbers a couple of years ago. I went to the NFL Combine website and I took some random people on there who play different positions, and I looked at their numbers on some of the different events at the Combine, and I converted their weight from pounds to kilograms, and I converted their speed from miles per hour to meters per second. So all these values are actually pretty realistic values, okay, for players in the NFL at least. Okay, so the question says rank the following from lowest momentum to highest momentum. So that means there's two parts to this question. Number one, that means you have to find the momentum of each of these 4 players. And number two, once you've found the momentum for each of those 4 players, you have to put them in order from smallest to biggest momentum. Okay, so I want you to try to do example 3 on your own. Okay, both parts, the momentum calculations and the ranking. And then after you enter your answers, I will tell you the correct answer to the question, and then we'll end the video. Okay, so hopefully you got the answer to example 3 correct. And again, this video is just an introduction to momentum video. We didn't do anything complicated in this video, just introducing the concept of momentum, basic calculations, etc., etc. In the next couple of videos, we'll do more complicated concepts and examples having to do with momentum. As always, please let me know if you have any questions, and I'll see you guys in the next video.